In canonical transformation, today we will see the concept of a very important identity which is actually known as Jacobi identity. In fact, this Jacobi identity finds its application in finding a constant of motion if you know two constants of motion. It means if two constants of motion are given, it is very easy to find the another constant of motion by the use of this Jacobi identity. So first of all, we will see what is this Jacobi identity or how this identity is defined, and after that, first of all, we will deduce this identity, and in the next lecture you will see the application of this Jacobi identity in finding a constant of motion. So let us see how this Jacobi identity is defined. You can see here the Jacobi identity is defined as we have defined in this equation number A. For this, let us consider the three dynamical variables. You can say U, V and W are three dynamical variables, and in this condition this Jacobi identity is defined like this as the Poisson bracket of the variable U and the Poisson bracket of V and W. It means you have to take the Poisson bracket of variable U with the Poisson bracket of the two variables V and W, and then we add it with the Poisson bracket of V and Poisson bracket of W and U plus Poisson bracket of W and Poisson bracket of U and V. Actually, the sum of these three Poisson brackets of these three dynamical variables is equal to 0. This identity is known as Jacobi identity. First of all, we will see how this Jacobi identity can be derived. And for deducing this identity, let us consider the expression. You can see here I have considered the expression Poisson bracket of variable U with Poisson bracket of V and W minus Poisson bracket of V and Poisson bracket of U and W. Now from the definition of Poisson bracket, you know the Poisson bracket of V and W will be defined like this. This is summation over I del V by del Qi times del W by del Pi minus del V by del Pi times del W by del Qi. This is just the definition of Poisson bracket. So by using the definition of Poisson bracket, I have written this expression for the Poisson bracket of V and W, you can see. And similarly, the Poisson bracket of variables U and W, this will be defined like this. Here you can see this is summation over I del U by del Qi times del W by del Pi minus del U by del Pi times del W by del Qi. Now for simplicity, let us consider this summation over I del V by del Qi times del W by del Pi. I have assumed that this is equal to M. You can see here. This is just for simplicity. And similarly, you can consider that summation over I del V by del Pi times del W by del Qi equal to N. And we also consider that summation over I del U by del Qi times del W by del Pi equal to O. See here, this is O, not 0, this is O. And summation over I del U by del Pi times del W by del Qi equal to R. We have assumed it for simplicity. So by this notation, M, N, O and R, the equation 1 which we have defined here can be now written like this. You can see that this expression for the Poisson bracket of U and Poisson bracket of V and W minus Poisson bracket of V with Poisson bracket of U and W. This will be equal to what? This will be Poisson bracket of U and M minus N. In fact, for this expression we have written M, and for this expression I have written here N. And similarly, the second term will be Poisson bracket of V with O minus R. O, you can see here, O is for this and R is for this. Now, by using the property of Poisson bracket which you have studied in the previous lecture, you can easily write what will be this Poisson bracket of U with M minus N. From the property of Poisson bracket, you can write this is equal to Poisson bracket of U and M minus Poisson bracket of U and N. And this minus, see here, for this minus I have written here minus sign, and Poisson bracket of V and O minus R will be equal to what? This will be Poisson bracket of V and O and minus Poisson bracket of V and R. But since here there is minus sign, so this minus will here become plus. So this is minus Poisson bracket of V and O plus Poisson bracket of V and R. Now again, use the expression which you have assumed for M. You can see here M has been written for this expression summation over I del V by del Qi times del W by del Pi. So instead of M, I have again written here that expression. And for N, this expression has been written which we have assumed earlier. Similarly, for O and R, we can write the expression which I have mentioned it here. You can see it. And so this expression becomes like the equation defined in equation 2. Now we will simplify this RHS of equation 2 by using an important property of the Poisson bracket. You can see this property. So using the property you have studied in the first lecture on Poisson bracket, this property of Poisson bracket, which says Poisson bracket of U and V times W. What is this? This is actually equal to Poisson bracket of U and V times W and plus Poisson bracket of U and W times V. You have studied this property. Now using this property of Poisson bracket, what will be the form of RHS of this equation 2, you can easily see. You can see what we can write the RHS of this equation 2 by using this very property of the Poisson bracket. So using this property, we have from equation 2, you can see in LHS of equation 2, you can see there is Poisson bracket of U with Poisson bracket of V and W. Poisson bracket of U with Poisson bracket of V and W. And minus, what is the second term? Poisson bracket of V with Poisson bracket of U and W. So this is Poisson bracket of V with Poisson bracket of U and W. U and W. And what will be this? You can easily see here. The first term is Poisson bracket of U and this much. You can see, which I am underlining here. You can see. Now this is just a product of two dynamical variables, summation over I del Vi by del Qi times del W by del Pi. So in the light of this property which I have mentioned here, you can write the first term in the RHS in this manner. You can see here, this is equal to Poisson bracket of U and summation over I del V by del Qi. You can see summation over I del V by del Qi times del W by del Pi times del W by del Pi, summation over I del W by del Pi, and plus, now for this term you can see this will be Poisson bracket of U and summation over I del W by del Pi and times summation over I del V by del Qi. Del V by del Qi. You can easily recognize this equation by the use of this property which I have mentioned here. In fact, this expression has been written for the first term in RHS, you can see. Now for this second term, since there is minus sign here before the second term, so both of the terms for this will be negative. So this can be written as minus Poisson bracket of U and summation over I del V by del Pi. You can see I am writing the expression for this which I am just underlining here. So this will be Poisson bracket of U and summation over I del V by del Pi times summation over I del W by del Qi times summation over I del W by del Qi, and again minus because minus sign is before the second term. So this will be what? This will be now Poisson bracket of U and this much summation over I del W by del Qi times summation over I del V by del Pi. You can see. So this expression has been written for the second term in RHS of this equation 2. Now for the third term, you can see the third term and there is minus sign before this third term. So when you will expand this third term by the use of that formula, then again both of the terms will be negative, and you can easily write what will be this. See the this term. So this will be actually minus Poisson bracket of V and summation over I del U by del Qi. Del U by del Qi times summation over I del W by del Pi. You can see here Poisson bracket of V and this much summation over I del U by del Qi times summation over I del W by del Pi. Now in the second term the factor will be interchanged and this will be minus Poisson bracket of V and summation this is actually common, summation over v comma summation over I del w by del pi and times summation over I del u by del qi. Del u by del qi. Now see the fourth term in the RHS of this equation 2. This is your fourth term. And we will again simplify it by the use of that very property. So you can see what will be this. This is plus Poisson bracket of V and summation over I del u by del pi and times summation over I del w by del qi and plus Poisson bracket of V, and now we will write this much, summation over I del w by del qi times summation over I del u by del pi. Now we will simplify this RHS of this equation a little more. You can see here. You can take this del w by del qi or minus del w by del qi as a common factor, and you can see in this term which I am crossing here, this term contains some minus summation over I del w by del qi, and again this term which I am crossing here also contains summation over I del w by del qi. So let us take this minus del w by del qi as a common factor. So you can simplify this in this way. This is, I am writing summation here and this is summation over I minus del w by del qi. Summation is already implied here. And now see, when you will take minus del w by del qi as a common factor, then what will be in this term you can see here. So since in the last term which I am crossing here or underlining here, you can see there is a plus summation over I del w by del qi, but you have taken minus as a common factor. So here we will interchange the variables inside this Poisson bracket. So we will write this in this manner. This is Poisson bracket of del u by del pi and v and plus, now see this term. In this term already minus summation over I del w by del qi is present. So here order of the variable inside the Poisson bracket will not change, that will remain same. So this will be plus Poisson bracket of u and del v by del pi. Del v by del pi. Now, now let us take this summation over I del w by del pi as a common factor. So this term which I am just underlining here, you can see contains this del w by del pi, and this third term also contains del w by del pi. So taking this del W by del Pi as a common factor, what will be our result? You can see. This is del W by del Pi. I am just taking it as a common factor, and summation is written here. This is applied for all of the terms containing the subscript I. So this is del W by del Pi, and Poisson bracket of, you can see, del W by del Pi. But in this term, you can see there is minus sign here, minus minus V comma del U by del Qi, del U by del Qi. But I have taken here plus. So this minus will become plus when we will interchange the variables inside this Poisson bracket. So now you can write it as Poisson bracket of del U by del Qi and V and plus. Now see this term. This contains actually summation over I del W by del Pi, and this is already positive. So here the order of the variables inside the Poisson bracket will remain same. And so this is Poisson bracket of U and del V by del Qi. Del V by del Qi. You can see. So this summation over I is applied for all of these terms. Now see the terms in the another column. Here there is in fact del V by del Qi, you can see, and in this term too, in fact here there is only one term containing this del V by del Qi. So we will not take it as a common factor, but we will again write this term, which is the second term in the RHS of this equation. So what will be this? This will be plus summation over I. I am again taking this summation as a common factor, and this will be del V by del Qi. Mark this. And Poisson bracket of what? Poisson bracket of U and this much. You can see here. Poisson bracket of U and del W by del Pi. Poisson bracket of this much. Now, again you can see there is del V by del Pi here with minus sign. So write the minus sign here, and there will be del V by del Pi times Poisson bracket of what? Poisson bracket of U and this much. You can see it here. This is, page has been turned, but it will be okay. Now you can see. Yes, this is del V by del Pi times Poisson bracket of U and del W by del Qi. Del W by del Qi. And now see here, in this term there is summation over I del U by del Qi times this much. I am in fact writing this expression in another page, but this sigma sign will be also applied for that term. So you can see there will be what? This will be actually equal to minus del U by del Qi times Poisson bracket of V and del W by del Pi. Del W by del Pi. And now the last term. The last term, in fact, this will be summation over I del U by del Pi times this much. So this is plus del U by del Pi times Poisson bracket of V and del W by del Qi. Del W by del Qi. And say this is your equation 3. So you can see, using this property of Poisson bracket, I have simplified the expression for this here. Now we will simplify this result by using a very important identity. Using the identity del x Poisson bracket of two variables x and y. You know this is equal to Poisson bracket of del x by del x and y plus Poisson bracket, sorry, this is plus Poisson bracket of x and del y by del x. Del y by del x. And by the use of this very important identity, you can see the first term in RHS of this equation up to this. Mark this and this. Using this very property, this can be written as minus del W by del Qi times Poisson bracket of del Pi U and V, and plus del W by del Pi times Poisson bracket of, del W by del Pi del Qi Poisson bracket of U and V. By the use of this property, you can easily see. So equation 3 becomes, what will be now this equation 3, you can see. First of all, we will write the expression in the LHS of this equation, and you can see this is the expression in LHS. So just rewrite this. This will be Poisson bracket of U with Poisson bracket of V and W and minus Poisson bracket of V with Poisson bracket of U and W. And this will be equal to, as I have told you, by the use of that property, you can write expression for this term. What will be this? You can see this will be summation over I minus del W by del Qi times del Pi operated on Poisson bracket of U and V, and plus you can see del W by del Pi times del Qi and operated on Poisson bracket of U and V, and plus. Now see these terms. In fact, when you will simplify these terms from the property which you have written here, then you will find that all these terms when will be added will vanish. In fact, I am not doing that a lot of algebra, but I have left it for your homework. You can use that property and you will find that the remaining term will simplify to be 0. So I am just writing directly that the remaining term will be 0. So this is 0. Now see, again you can see this property which I have mentioned here, that this is del w minus del w by del qi del pi and Poisson bracket of u and v. So here at the place of dynamical variable there is Poisson bracket of u and w. So this, if you consider that this Poisson bracket of u and v is equal to, let us say p, then this will be minus del w by del qi times del p by del pi plus del w by del pi plus del p by del qi. So this will be nothing, this will be simply the Poisson bracket of w and p, but p you have assumed instead of this Poisson bracket of u and w. So you can say that this is nothing, this is simply the Poisson bracket, sorry, here there is minus. So take this, I am not writing the next term, but here I am just simplifying this expression in this manner. Now let us take this minus sign as a common factor. So if you will take minus here as a common factor, then this first term will be plus and this second term will now become minus. The second term, this will become minus. So write here minus sign. Then according to the definition of Poisson bracket, this expression is nothing. This is simply the Poisson bracket of w and u, Poisson bracket of u and v. So from the definition of Poisson bracket, you can write this, that this is minus Poisson bracket of w and Poisson bracket of u and v. So now let us take this result, this term which we have obtained in the LHS. So you can see this will be Poisson bracket of u and Poisson bracket of v and w. This is actually the first term in LHS minus the second term is this much. So rewrite this. This is Poisson bracket of v and Poisson bracket of u and w. And when you will take this term in RHS, in LHS, this will be plus Poisson bracket of w with Poisson bracket of u and v, and this will be equal to 0. But this minus sign will become plus if you interchange the order of the dynamical variables inside this Poisson bracket. So you can write it in this way. This is Poisson bracket of u with Poisson bracket of v and w plus Poisson bracket of v with w and u, and plus Poisson bracket of w with Poisson bracket of u and v, and this is equal to 0. And now you can see the result which you have obtained here is nothing. This is simply the Jacobi identity. So you can say this is Jacobi identity. So in this lecture I have only derived this important identity, not discussed it. But in the forthcoming lecture we will discuss this identity and we will also solve the problems based on this identity, and you will see that when two constant of motion are known, then this identity can be used to find the another equation, another constant of motion.